Let's hack your IGCSE math exam. Today, we're completely conquering graph sketches in record time.
Picture this. The exam clock is ticking, and plotting every single coordinate is just eating up your time.
The real cheat code? Memorizing the visual personalities of the 5 core graph families.
We're counting down the top 5 shapes you need to know, starting at number 5.
Coming in at number 5 is the linear graph. It's just a perfectly ruled, continuous straight line.
The trick here is the rule of 0. Plug in 0 for x or y to find quick intercepts.
Moving up the complexity ladder to number 4, we've got the absolute classic, the U-turn. Quadratic graphs form this beautifully symmetrical U-shape. They'll open upwards or downwards depending on your equation. To score full marks here, find that turning point. Usually, you'll use the completed square form to get it.
All right, hitting number 3, let's see what happens when things get a whole lot curvier.
Enter the cubic graph. These are famous for a dramatic double bend when crossing the axis multiple times.
Watch out though, because dropping a simple negative sign completely flips the entire curve's direction backwards.
Now, before hitting our top 2, we have to talk about a major danger zone, dividing by 0.
That creates an asymptote. It's basically an invisible force field your graph can get super close to but never touch.
Which brings us straight to the ultimate rule breaker at our number 2 spot.
The reciprocal graph. Look how this curve literally fractures into 2 pieces just to avoid the axes completely.
It packs 2 distinct asymptotes and a cool diagonal symmetry that totally sets it apart from standard polynomials.
And finally, taking the crown at number 1 for sheer, explosive, and dramatic growth,
the exponential graph. It starts off ridiculously slow, but suddenly rockets upwards towards infinity.
Just remember, exponentials only have one single asymptote, and you always got to draw it as a dashed line.
So, here's your final cheat sheet, mapping out every shape and invisible boundary. Snapshot this for exam day.
If you can master this universe of simple curves, what complex math problem are you going to crush next?